of 2 is now, instead of using the square root property, factoring, quadratic formula, graphing calculator, whatever it is to decide what kind of solutions we have, there's some equations that look quadratic in form. And so they have this idea called the substitution. So bear with me because I don't think we really need to use it on this one. I wouldn't use it on this one, but I'll show you how they teach it, okay? So the substitution idea is, hey, this is not x squared and this is not x. But this is something, it's this one squared. So whatever your middle term is, let that be your substitution. So let u equal x squared. They call it u substitution, okay? What do I mean by that? Well, how does x to the 4th relate to x squared? It's the square of this. So if x squared is u, this is just rewritten as u squared minus 5u plus 4 equals 0. I personally would not use u substitution on this one. I would factor it like we're used to using the AC method. And at the end, when we get x squared and x squared, we'll take the square root and use the square root method. But I want to show you how you can do it. I would use it over here. Like, this is more obvious to me. Okay, so what we're going to do is we're going to factor like normal. So our a is 1. So our AC is 4. What are factors of 4 that add up to negative 5? Negative 4, negative 4, 1. So we're going to use u squared minus 4u minus 1u plus 4 equals 0. And then we're just going to factor like normal. What can you pull out of the first two terms? U. And so then you're left with u minus 4. And then what can you factor out of the back two terms so that you're left with a u minus 4? Negative 1. So at that point, we have two terms that have a common factor of u minus 4. So you have u minus 4 times u minus 1 equals 0. So we use the product property, meaning if you have two things that multiply to be 0, one or the other is 0. So set them equal to 0 and solve. So you get u equals 4 and u equals 1. Is that where you guys are right now? Okay. So then you put those in, and my math will be like, well, what is u? Where did u come from? Like, I gave you x's. Why are you solving for u? And you're like, oh, yeah, that's right. U was my placeholder. It was my substitute, right? So what was u? X squared. So I can just say u was x squared. So really, x squared equals 4. And x squared equals 1. And then you can just use the square root method, right? We'll take the square root of both sides, put a plus or minus in front. So what do you guys get? You get x equals plus or minus 2 as well as plus or minus 1. So you get 4 answers. 2, negative 2, 1, negative 1. And typically, the power of your polynomial, so notice that it's a 4th degree polynomial, that's usually how many answers you have. So notice we had 4 answers there. Would I use u substitution here? No, I would probably factor it with, like, what you would have gotten, guys, was x squared minus 4, x squared minus 1, and you could use the square root property to solve those. Here I would do it. So again, notice this middle term is singular, and this is just the square of it. So let that middle term be u. So u equals 2x minus 3. So how can we rewrite this quadratic? Well, what was 2x minus 3? U. But what are we doing to u? Squaring it. So that is just u squared. Minus 5 times 2x minus 3. But what is 2x minus 3? U. And then plus 6 equals 0. Do you guys see how I did that? So instead of having this like cumbersome binomial 2x minus 3 floating around, where we see 2x minus 3, we're just going to plug in a u, right? So this is u, but what are we doing to it? Squaring it. That's just u, but what are we doing to it? Multiplying by a negative 5, all right? And so at this point, it just kind of like makes it a little bit more concise. So what are factors of 6 that add up to negative 5? Negative 3, negative 2, right? So we can rewrite this as u squared minus 3u minus 2u plus 6 equals 0. And then we can factor the u out of the first term to leave us with u minus 3. We can factor the negative 2 out of the second term to leave us with u minus 3. And again, binomial that they have in common is that u minus 3. And it leaves us with a u minus 2. Is that okay so far? So zero product property says set them each equal to 0. So u minus 3 equals 0, u minus 2 equals 0. So u equals 3 and u equals 2. And again, my math lab will be like, what the heck is u? Where did he come from? Well, u was our concise little way to plug in 2x minus 3, right? So what I'm going to do at this point is n for u on the left-hand side. I'm going to say, well, u was really 2x minus 3. But if u is equal to 3, so is 2x minus 3. And u was really 2x minus 3. So if he was equal to 2, then 2x minus 3 is equal to 2. And then you'll move your 3 over and divide by 2 on both of those, all right? So we'll add the 3 over to the first one, and we'll be left with 2x equals 6. So x equals 6 on one of them. And then we'll add the 3 over to the other one. So 2x equals 5. So x equals 5/2. Okay? This u substitution, guys, oh, I didn't do that right. 6 divided by 2 is not 6. Should it be 3? Sorry. I didn't divide by 2. So do you really need to use u substitution? No, I might have a problem on it, but if I do, it's probably more like this. But how could you get around it if, like, worst case scenario, you didn't remember how to do it? Factor this one like normal, but use, x squared and x squared when you split it up. This one, you could technically FOIL, distribute, gather like terms, and get a totally different quadratic that you could use the AC method on that one. So like here you could distribute the -5, here you could FOIL this, and you can gather like terms, and you get a completely different quadratic whose answers, when you factored them, would give you 3 5/2. Okay, so